In math, we often group numbers and variables together to create expressions, equations, and functions. These are very similar, but there are some subtle differences with them. So expressions do not have equal signs in them, whereas equations do have equal signs. For example, if I have something like this, if I had 2x plus 3, this is what we would call a mathematical expression. But if I were to say 2x plus 3 equals 7, now I have an equation. That's because an equation is going to have an equal sign. Equations have expressions on both sides of the equal sign. Okay? There's also functions. Now, functions are going to be types of equations that demonstrate relationship between two or more variables. Now, at this level, most of the time, we think of these as two variables. A lot of times you would see f of x equals 2x. Okay? Or you might see y equals 2x plus 3 for a linear equation. Well, that could be a function. But we know that there's actually a lot of variables in real life. So for instance, if you were to think about taking out a loan, you might have the loan length, how much money you would want to take out, your monthly payment, the interest rate, how frequently you're making payments. All of these things are different types of variables. So in real life, there's a lot of variables. Most problems have more than just two variables in them. Something else to think about is that expressions oftentimes have their own wording to it. So do equations and so do functions. For example, expressions, most of the time, you might just see something like where people tell you to simplify. So if you see the word simplify, then you probably are working with expressions. Equations, you would often see the word solve. So when you see solve, it's very likely that you have an equation. You actually cannot solve an expression. And that is something I hear people kind of mix up a lot. They're like, oh, do you just want me to solve this? Well, we can't solve this. Solving means finding the value of the variable that makes the equation true. But if there's no equation, if there's no equal sign, then you can't actually solve it. But you can simplify expressions. That may mean combining like terms or doing some reducing. And then functions, a lot of times you might see something like this where it'll say evaluate or it might say graph. Those are some things where you would frequently see with functions. Now, I also put up here that the numbers or variables that are separated by plus or minus signs are called the terms of the expression. So for example, in this expression, I have two terms. I have 2x and I have a 3. Notice they're separated here with this plus sign. Right, I have three terms down here. I have a 2x and I have a plus 3. So this expression has two terms to it. The expression on the other side of the equal sign, 7, that has just one term to it. We're going to be spending most of the rest of this lesson on solving equations. Now, an equation is a mathematical sentence that states one expression is equal to another. You can see up here in our very basic example, we have the expression on the left, 2x plus 3, and we have the expression on the right, 7. Okay, so they just have an equal sign in between. A solution to an equation is any time that you can replace the variable with a value and it makes it true. So it's the value of the variable that makes the equation true. We can find these out by substituting them back in and verifying that they work. So we're going to check this and see if -1 is a solution to this equation. Once again, just like before, you can see we have an expression on the left side, we have an expression on the right side, we have an equal sign in the middle, so this is an equation. You can see there's two terms on each side. We have a 7x and we have a 2, so there's two terms there. And there's two terms here. They're separated with the negative sign on the left, or a minus. We separated with the addition sign on the right. So when we substitute -1 in, you'll see I'm just going to substitute this in here, and I like to use parentheses so that I remember I'm multiplying. So we'll substitute that in. Now we can start to simplify the left-hand side. That just means maybe combining like terms or doing some of the multiplication. So 7 times -1 is -7. minus 2. And on the right-hand side, 4 times negative 1 is negative 4 plus 5. On the left-hand side, I've got negative 7 minus 2. Negative 7, and then make it even more negative. So that will become negative 9. You could think of this if you were on a number line and we were at negative 7. When we say minus 2, this means go to the left by 2. So you would go 1, 2 more to the left, and that's where we end up at negative 9 there. On the right-hand side, I have negative 4 plus 5. So I would start at negative 4. 1, 2, 3, 4. Right here's negative 4. And when it says plus 5 means go to the right. So 1, 2, 3, 4, 5. And that's how I end up over here at positive 1. So this is just 1. Negative 9 on the left, 1 on the right. Look at this. That's not true. That's no good. So what we would say is that negative 1 is not a solution to this equation. When we tried substituting negative 1 in to the equation, it does not balance, right? The left side, this definitely not a true statement. Negative 9 equals 1? No, it's not. All right, let's go down and look at the second equation. Verify that 2 is the solution to this equation. So just like before, we'll substitute a 2 in for the x. So we'll substitute the 2 in everywhere we see an x. I just put it in with parentheses. This is now 5 plus 4 equals 15 minus 6. 5 plus 4 is 9. And then on the right side, I have 15 minus 6. That's also 9. Now, 9 equals 9. That works. So we can say that 2 is a solution to this equation because the left side equals the right side when x equals 2. So I know this doesn't say verify that 2 is a solution. This is very much implied that x is equal to 2. Just like up here, is negative 1 a solution? This is very much implied that that means let x equal negative 1 and then substitute it in. Now, when we look at the solutions to some equations, these three equations are all very different with their solutions. So I'm going to show you what those different situations might look like. On this first equation, if I were to tell you x is 4, I would say most of you would probably believe me just fine because in your heads you know that 4 plus 1 is 5. Now, that means that this equation has one distinct solution. There is only one answer to this. X can be 4, and that's it. We could also call this a conditional equation. We would say that it's a conditional equation because it's true, but only under the condition that x equals 4. Right? When x equals 4, this equation is true. When we look over to this next one here, I'm going to tell you that x can be any real number. Now, probably you believe me, because if I let x be 10, I would have 10 plus 3 equals 10 plus 3. Yeah, 13 equals 13. If I told you that x is 100, 100 plus 3 equals 100 plus 3. Yeah, that's true. It works for negatives, it works for fractions and decimals. X can be any number here. So for this one, there are infinitely many solutions because x can be any real number. Now, in addition to that, we would also say that this is a dependent system or an identity. For our last equation, here we can see x plus 3 equals x plus 4. Well, I can't think of any number that will work for that. So nothing works. There's no real solution. Or I might even just say that there's no value of x that will work. So doesn't matter what you think. If you try plugging 10 in, I'd get 10 plus 3 equals 10 plus 4. That's not true. So this is no solution. Now, there's a number of ways that you can express this. 1, you can just write no solution, right? That's actually one of my favorites. Some people like saying it like this. They use this little 0 with a slash through it. This is called the null symbol or the empty set, and it just means no solution. You could also say like this. You can put it inside braces, but put nothing there. Leave an empty space in there. So now this is also known as the empty set. All three of these are just fine. Some people prefer one over the other. No solution is just as easy as anything. It doesn't really matter. Lastly, then, we can also say that this is an inconsistent equation. That's different than the first two that we looked at. These two would be considered to be consistent because solutions exist. So the one on the far right is inconsistent because there's no solution. There are solutions to the first two, so those are consistent. Now, when we solve basic equations, what we're going to do is we want to try to isolate the variable. We want to get the variable all alone on one side of the equal sign. That means getting rid of all the constants, the coefficients, everything. We want it to ultimately just say x equals something or y equals something. So we want to isolate the variable. We're going to do that by using inverse operations. So if something's being added, we're going to subtract it. If something's being multiplied, we're going to divide it. What we're going to be doing here is we're trying to balance both sides of the equation. So we use these inverse operations, but whatever you do to one side, you have to do to the other. Ultimately, you can verify whether or not you have the correct answer by substituting them back into the original equation or just plugging it in. So if you look at our first example where we're actually going to solve an equation using inverse operations, I see this as x plus 5. Well, I'm going to undo this plus 5 by subtracting 5. Now, whatever I do to one side of this equal sign, I'm going to do to the other. Some people need to put a little line here. I won't do this all the time, but if you struggle with equations, with simple equations, it's a good idea then just to draw a vertical line straight through your equal sign. And so now you know, whatever you do to one side of this equal sign, you got to do the same thing to the other side. I subtracted 5 from the left. So positive 5 and negative 5, they're going to cancel out, right? But what happens is they add up to be 0. So this is really just now saying x plus 0. But if I have x plus 0, I mean, we don't talk like that. We don't say like, oh yeah, I have 0 Lamborghinis. We don't go around telling people all the things that we don't have. So if it's just x plus 0, we'll just write it as just x. Okay. And then on the right-hand side, we do get 7. So x equals 7 would be my answer. Now, I can always check that by substituting it back into the original equation. If I take 7 and put it in right here for x, what I get is 7, oops, put that in parentheses, 7 plus 5 equals 12. And then I would say 12 equals 12. Yeah, that's good. I like that. That works. So that means that x equals 7 is a solution, and I can box it and feel confident that it's right. Over on the next one, if I have x minus 4 equals 18, I'll undo this minus 6 by adding 6 to both sides. So I'll say plus 6 on the left side of the equal sign and plus 6 on the right side of the equal sign. Again, if you need to, you can draw a vertical line straight through here so that you know whatever you do to one side of the line, you got to do to the other. But if you don't think you need that, then don't do it. That's okay. I do have negative 6 and positive 6. Those are going to add up to be 0. And so on the left-hand side, all I have left is just x equals. And on the right-hand side, I have 18 plus 6 is 24. So these are one-step equations. I got x equals 24. When I substitute it back in, I'm only doing one step to undo that, right? 24 minus 6 equals 18. Yeah, that's a true statement, so I'm good. That's true. This is the solution. It's the value of the variable that makes the equation true. Here's a few more examples of some one-step equation. This first one I have 3 times x. When we have a coefficient of 3 and a variable of x, this coefficient just means 3 times that amount. So to undo it, I'll divide the left side by 3 and divide the right side by 3. Now most of the time whenever we talk about dividing, we'll just, jump on ahead. There we go. We'll just end up using this. We'll just say divided by 3 on the left and divided by 3 on the right. So that's x equals 9. Now, I'm not going to go through and plug all of these back in and check them. That's because I feel very confident that I can do these one-step equations and get them right. If you feel like you need to check them, you should definitely do that. Don't just do it and guess and be like, I don't know if I got it right. That's the really nice thing about math is there's a lot of these equations that you can take your answer, plug it back in, and verify that it works. Over here on the next one, I have -5 times x. So to undo that -5 times x, I'll divide the left side by -5 and divide the right side by -5. Now, there's a lot of people who will say like, oh, these -5s cancel, right? Cancel. Well, that's sort of true, but really what's happening here is -5 divided by -5 gets me +1, and then I have 1x. But if I have 1x, usually we'll just call that x. And over on the right-hand side, 35 divided by -5 is -7. So I do get x equals -7. Okay, and we did that by doing the opposite of the multiplication, which is to divide by -5. On the next one now we have a fraction. So this is x divided by 4. And you probably know that the opposite of dividing by 4 is multiplying by 4. So I might say like times 4 and times 4. But instead of writing it down there, I'm going to write it on the side, I think. So I'm going to say times 4. And the other thing is any number can be turned into a fraction. All you do is put it over 1. So we'll multiply the left side times 4 and the right side times 4, or 4 over 1. Now, if you feel like reducing, and you could say this 4 and this 4 will simplify down to just be 1. So then what we have is just 1x on the left-hand side. That's just fine. If you want to actually multiply these, what you would get is 4x on top, because you would take 4 times x. And then on bottom, you'd have 1 times 4, which is just 4. And on the right-hand side, 12 times 4 is 48. Over here, that idea of simplifying, right? 4 divided by 4 is 1. So I have 1x, or just x equals 48. Okay. On this last one here, this is x divided by -3, so I can multiply both sides by -3. I'm going to put this in parentheses so that I don't forget and think that that's accidentally subtracting. Now, once again, any number can be turned into a fraction. You just put it over 1. So I'll do that. And on this right-hand side now, multiplying by -3 undoes this dividing by -3. So you can either do what we did over here, which is to multiply them out and simplify them in the end, or we can say, I know that -3 divides -3, and that just becomes 1. So I get x on the left-hand side. And on the right-hand side, we multiply directly across the top. 2 times -3 is -6, and 5 times 1 is 5. So I get x equals -6/5. For these next couple, I still have some fractions, which I know some of you might be stopping, you're turning off the video, you're just leaving because you just don't like fractions. But this really is a very similar problem to what we've already done. Look at this. If this was just like x plus 1 equals 5, you guys would have no problem with that. You'd say, oh, we're just going to subtract 1 from both sides. Yeah, that's really what we're doing on this problem. We're just going to subtract a 1/3 from both sides. Okay, so this is x plus 1/3 minus 1/3. Those are inverse operations, and those will sum to be 0. So this is like saying x plus 0, which again, we don't usually write that. Instead, we would probably just say just x. Okay. And then over here on the right-hand side, I have 5/3 minus 1/3. I'm going to go ahead and write this out. If you had 5 cars and you took away 1 car, you'd have 4 cars. Right? If you had 5 dogs, take away 1 dog, you'd have 4 dogs. Here you have 5/3, take away 1/3, which is equal to 4/3. We just get x is equal to 4/3. When you're adding or subtracting fractions, you just need to have common denominators, which we do. They're thirds in this case. Okay, fraction's not so bad. The next one over here, we do have 2 times x equals 1/5. Most students just go like this. They say, oh, I divide by 2 and then divide by 2. But the problem is I have this complex fraction over here on the right. 1/5 divided by 2, that's kind of weird. So you can think about it a couple different ways. 1/5 divided by 2 is just fine, because most people learned that if you have 1/5, you can keep the first one, you can change the sign, and then flip the second one, or in other words, multiply by its reciprocal. So to divide by 2 is the same as multiplying by 1/2. So on the right-hand side here, I just have x equals, and then 1/5 times 1/2 is 1/10. And that's it. Okay. Another thing that you could do if you wanted to, clear this out, is if you don't like just dividing by 2 and having those crazy fractions over there, you can also think about this. What would I multiply this by to undo this 2? Well, if you multiply by its multiplicative inverse, or in other words, if we just multiply the left side times 1/2, half of 2 is 1, and that will turn this into just 1x. On the right-hand side, whatever you do to the left, you got to do to the right, so this would just be times 1/2. That gets us 1/10, and it's still the same thing. It's still doing the same thing as what we did before. Okay. Our last couple examples here, I'll solve these 2 different ways. One way would be to clear the fractions. I see that I have a denominator, so if I multiply the whole left side times 3 and the whole right side times 3, now I know that 3 cancels with 3, or I should say 3 and 3 will simplify to be 1, because remember, this is over 1. If I have the same factors in the numerator and the denominator, they will divide out. So that does leave me then with 2x on the left equals 12. And then my last step would be to divide by 2. I get x equals 6. Okay. Similar idea over here. I can multiply both sides by 5. I'll take this times 5 over 1. And we'll take this one times 5 over 1. I did that so that I can clear out the fraction that's over here. That does get me just 4x on the left, and then it's 35/4 on the right. We're back to this idea where you can divide by 4, or you can multiply by 1/4. So I'm going to choose, I'll go ahead and I'll say divided by 4, and then divided by 4, just as a reminder what that looks like. 35/4, and then we have divided by 4. Okay. So remember, to divide by 4 is the same as multiplying by the reciprocal. This would be times 1/4, which is 35/16. Done. Now, this actually isn't my favorite way. I would prefer to do this in one step. So I told you I was going to show you 2 different ways to do this. Let's clear this out. We're going to do the same thing, but we're going to do each one of these in one step. That's because this whole section is dealing with one-step equations. If this is 2/3 times x, I can undo that with its multiplicative inverse, meaning its reciprocal. If I multiply the left side by the reciprocal of 2/3, look, 3 times 2 is 6. 2 times 3 is 6. And I know that 6 over 6 is just 1x. Or, as some of you might be screaming at your screen, oh, the 3 and the 3 will reduce. Those simplify to be 1. 2 and 2 simplifies to be 1. Yeah, however you want to do it. But the important thing is, whatever you do to one side, you've got to do to the other. So if I multiply the left side times 3 halves, I got to multiply the right side times 3 halves. This does get me 4 times 3 is 12. And 1 times 2 is 2. I still get 6. So if you multiply by the reciprocal, that's going to clear out this coefficient much quicker. You'll see that over here on this right-hand side if I go times 5/4 on the left side and times 5/4 on the right side. Okay, we can say the 5 and the 5 will simplify. We can say the 4 and the 4 will simplify. That leaves me with just x on the left-hand side, and I multiply directly across the top. 5 times 7 is 35, and I multiply directly across the bottom. 4 times 4 is 16, and I get x equals 35/16. As a quick reminder, you'll notice that all of the equations that we did here today, these one-step equations, these all fell under this first category where we had one distinct solution. They were conditional equations. So we were able to find answers to every one of our equations that we had, and we even checked our work. Okay, I didn't check my work on all of them, but remember that until you feel very confident that you're doing things right, you probably should check your work. Well, I hope this was helpful. I hope that you were able to work out your one-step equations. Make sure you keep practicing.